Hello guys, and welcome back to another tutorial. Today's tutorial is going to be on comparator math. I'm sorry for last episode saying that I was going to be doing busing, but we need to understand the logic of comparators for part of the busing I wanted to teach you in that tutorial. So we have comparator math. So first things first, we need to understand about signal strength. If I turn my lever on here, I have 15 signal strength here, and each piece of redstone I add, that signal gets lowered by 1 until it gets to 1. The problem is these signs are actually inverted. This should be 1 and this up the far end should be 15. And after we get to 1 signal strength, it goes to 0. So we understand signal strength. The reason why we need to learn about signal strength and understand it is because comparators use it in order to work. So moving on to our first mode of a comparator, the positive mode. If the power is equal to the equalizer, we will power the amount of signal strength our power has. That was kind of said a bit strangely, but the purpose of this is, when I pull the power, I have a 15 signal strength going in. It gives out 15 signal strength. If I turn on my equalizer, it still outputs. The point of the equalizer in positive mode is, if you have a smaller power signal strength than you do equalizer, it will turn off. So if I just demonstrate this by coming out one, and now you can see that I've actually lowered it to 14 when I get here. If I turn this power on, oh sorry for that, you've noticed that I have no power output. The whole purpose is, it will only output when the power is greater than the equalizer. This is kind of like a fuse. If you go over the amount that you need to, the equalizer would tell it not to output. So that's the positive mode. Now let's move on to the next one. We have the negative mode. Now this one is kind of in the name, negative mode. So basically the way the negative mode is it takes away the signal strength from the power. So yet again we have our power and our equalizer. If I put 15 in, and I take away 15, I get 0. But if I was to make this longer, for example, I'm going to extend it out here. This is now 15, take away 1, 2, 3, 4, and 4 take away 15, because you've got... So, the reason why I'm doing that is because if I power it from here, I get 15 signal strength. I've moved away an extra 4, so I'm at 11. So if I power it from here, and I come out here, we have 3, 4, 5. Oh, we have a 3 signal strength right there. We have 15 take away 4 equals 3. And that's kind of confusing. Whether that's done wrong or... Oh yeah, sorry. I understand why this is working. This is 11. This is 11 because if you come from here, it's 15, 14, 13, 12. Okay, sorry for that little confusion, but I'm getting it mixed up the other way. I'm thinking that that's a 4 signal strength. It's not. It's a... You start from here as 15 and go 14, 13, 12. So it's 12, take away 15, equals 3. So the negative mode, all it does essentially is it takes away the signal strength from your power equal to the equalizer. So if your equalizer is set at 6, and in your power you have 7, it will output a 1. So that's the 2 modes. Now there's one more thing that I think you're going to already know, but comparators can actually give out an output according to a storage. So if I was to put an item of any kind in here, I would get a 1 signal output. So these can be used in many different ways, but I can add more, for example, and up that percentage. So now I've got 3 signal strength. Let's add the redstone to it, and as you can see, the more and more you add, the bigger the signal strength. This can be used for a lot of different things, but I'm not going to go into that. So all I have to say is thank you for watching this short little episode on comparator math. If you didn't understand any of it, go back, look over and see if I've explained it clearly enough. If not, leave a comment and I'll answer it as quick as possible. Thank you for watching, and the next lesson is probably going to be busing. So ways of lowering ticks, repeater lengtheners and all that good stuff. So thank you for watching.